I think one of the things that really separates us from the high primates is that we're tool builders. And I read a study that measured the efficiency of locomotion for various species on the planet. The condor used the least energy to move a kilometer. And humans came in with a rather unimpressive showing about a third of the way down the list. It was not too proud of a showing for the crown of creation. So that didn't look so good, but then somebody at Scientific American had the insight to test the efficiency of locomotion for a man on a bicycle. And a man on a bicycle, or a human on a bicycle, blew the condor away, completely off the top of the charts. And that's what a computer is to me. What a computer is to me is it's the most remarkable tool that we've ever come up with. And it's the equivalent of a bicycle for our minds.
Hello, and welcome to Cyberdeck Users Weekly. You were just listening to, of course, Steve Jobs giving his famous quote, obviously easy to misquote as the computer is a bicycle for our minds, but it's an equivalent to a bicycle for our minds. I think that's actually the phrasing. I'm not going to go back and listen again. And at the risk of sounding very disrespectful to one of the greats of the industry and one of the best lines to explain how to think about computers, I'm going to try to come up with my own one. So here we go. So, do you ever watch the bike racing in the Olympics when they're in a stadium in the velodrome? So it's like a banked track, like typically made out of wood, and they go very, very fast in a circle, and they wear spandex, and a lot of times, sometimes some of the races have like rolling starts, but some of the races they literally have like their team captain or whatever like holding their seat, like holding their bike up, like they're in a standing start, and it's kind of a powerless position. A bicycle really is only working when it's going fast. Some people can stall a bike and stand still, but you're really alive when you're going, like, I don't know how fast they go, 30, 40 miles per hour around the track. Maybe faster, who knows? I'm sure somebody knows, actually. So, and then, there's some pretty gnarly crashes. Like if you're trying to make a pass or something like that, you turn a little too hard, and then your wheels slide out from under you, and, your uniform gets all ripped up and you get road rash and stuff like that. Not that there's anything wrong with bicycles, but what if we thought of computing as, or the computer as a skateboard for the mind, right? Man, now that I actually say it out loud, that sounds really disrespectful. Sorry, Steve Jobs. So skateboarding is improvisational. It's just the opposite of riding a bike in a circle in a velodrome. It's repeated failure. Some of my favorite YouTubers, when they try to land a trick, they do it like they just do a montage of like failing at the trick 100 times, then they land it sketchily, then they fail another 50 times, and then they really land it, and they're happy with that take, or they're just tired, and so they go home and put up the YouTube video. Skateboarding is very much about a creative recombination to make a new trick. Like most of the basic elements of the tricks are known, but what if I added another 180 degrees of rotation to an existing trick? Or, what if I tried it fakie or switch? Or, what is the difference between fakie and switch? Who knows? I'm sure somebody knows. Also, there's no right way to skate. There are definitely different styles. Like there's street skating, and then there's jumping on a curb and over a bench and that kind of stuff. And then there's the more not formalized. Like a lot of the competition skating is like with half pipes and quarter pipes and bowls and stuff like that. But that's also a style of skating, and that's what skate parks are typically. You understand what skateboarding is. I don't think I need to explain this. But it's also way slower than riding a bike. I don't know if you've ever tried to use a skateboard for transportation. It's not actually a very efficient way of traveling. And maybe you can get bigger wheels, but then it's harder to do cool tricks with the big wheels. But it's much cooler than riding a bike, especially than riding a bike in a velodrome. Like, as efficient and amazing as someone riding a bike in a velodrome is, it is not the coolest way to look. You don't look casual. And I'm making an analogy here to computers. So what I'm saying here is that the trade-offs that we've made in the development of computers since the 60s have been going for sort of efficiency and raw speed, often at the expense of the ability to turn. You lack a lot of the flexibility to do exactly what you want with the computer. And in exchange, and I don't know if it's actually an exchange, but like what we have is the ability to do whatever someone else wanted you to do with your computer with some amount of power, speed, and efficiency, maybe. And maybe not always that, But computers have gotten very complex, very difficult to program. And they were always difficult to program. And they are always, as far as human tools go, very complex. But it seems to me maybe we've gone too far in certain directions. The best mind bicycle I've ever owned is my iPad. Because it's always fast, it's always responsive, and it's actually really secure. It's very streamlined and efficient at doing the very small set of things that it's designed to do. And some of that is just the form factor, but some of that is also of what it's designed to do, but also some of that is just arbitrary restrictions by Apple on who can make software for this. Who is allowed to write software, to write subtools for this tool. And coding on an iPad is like writing the wrong way in a velodrome. Like, it is the most beautiful and efficient and streamlined way to not create software. Because, maybe you could like SSH into like a remote computer somewhere and like do some web programming or something. And then there's like these very hacky things that have been built on top that like can like run an emulator almost to like execute C++ or whatever. And then there's like some Python. I've actually written some scripts for my iPad in Python, and that kind of works, but it's obviously going against the grain of that machine. And the glaring hole is that you can't make an iPad app on an iPad. You can't create the blessed version, or it really hardly anything that is a native application for the iPad using an iPad, other than like writing a little bit of Swift code and then you copy and paste it onto a real computer and like compile an Xcode. So what I want to try to do is think about what would a skateboard computer be like How do we get there? Actually, I don't know if I have anything in here about getting there. But what is skateboardness in computing terms? And this is definitely one of those ones where I feel kind of liberated by the podcasting medium of mostly just asking questions, throwing out some ideas. I don't really have a strong closer. I don't have a good solution or an obvious path forward, but I just want to riff on this idea. Thank you for accompanying me on this journey. So, why am I thinking about this? Obviously, because I'm still reading this book called The Cuckoo's Egg, where this it's this guy in Berkeley, and he's one of like a few system administrators for the science community's computing power. Like scientists literally pay by the hour to access these machines that they're administering. He notices a hacker in his system, and he starts fighting the hacker using computing tools mostly. And it really made me think of this, the classic William Gibson quote, "The future's already here, it's just not evenly distributed." Like, people use computers right now as skateboards. And people in 1989, when this book took place, this guy was totally using his computer as a skateboard in the sense that I'm going for. And I'm just finding myself really jealous of how much agency this guy has over his computer. It seems like a much more powerful tool in his hands than any of my computers, with all the advantages I have of 31 years later and FiOS, I don't feel as powerful as he seems to be. So he's tracking this hacker, and he also has like this day job. He's an astronomer, and he's phoning it in as an astronomer by like writing software for other astronomers, which is entertaining in itself. So here are some of the skateboard things he does with his computer. So he physically intercepts the hacker's connection to his system and wires that up to printers. I'm sorry if I'm spoiling this book for you, but it's been out for a while. One of the first ways he does that is he has to tap like every line that he suspects and wire, like he steals computers from around his whole campus, or at least his building, steals computers and printers, like old computers, old printers, and wires them up to each individual line to print out. In a sense, what a pain in the ass. But it's also kind of cool that he can do that. I don't really want it to be easy for anybody to just tap into my communication lines, obviously. But there's just something interesting about that. So he's like taps into the line and then prints out everything that comes through that line, like all the instructions. When later on, he sets up this system so that when because he has like a system at his desk to alert him when the hacker is logged on, because he figures some stuff out about that, and he'll sleep at his desk or under his desk, waiting for this hacker to show up, and it's harming his home life. So he buys a pager. He gets like I don't even know what it's like a telephone dialer at Radio Shack. I don't even know what that is really. But basically an interface from his computer to a phone to call his pager, because pagers would work through a call. And then on top of that, when and this is an alert system for him so he can be out and about and be alerted that the hacker has logged on. And it even sends a message in Morse code to him so that he knows which account the hacker is using at the time. That's really cool. I don't know how I would do anything along those lines. There are definitely some centralized services. I could probably wire something up, right, to send a text message based on some sort of notification. But for me, it'd be a little bit of a stretch. Also, it feels like I would end up relying on a lot of centralized services to do that. And maybe that's fine. And, the phone system he's relying on is obviously pretty centralized. So it's not like that's impossible, but it's pretty cool. And it's kind of rare way of how we, like, notifications on our phones are almost all generated by other people, how many of the notifications are the things that we truly decided to have be the notifications that we want for very specific knowledge, not just knowledge that an app developer, requested permission to share with us, but something that we thought we needed to know. Because obviously he's in a novel situation and he's able to write tools that are responding to that novel situation. For his day job, he writes a computer simulation of a telescope bending, because apparently telescopes bend when they're pointed towards the horizon because of gravity, and it's, very sensitive instruments. It's not related to the hacker, but it's still pretty cool. Something I wouldn't know how to do. And obviously there are people that exist right now who could do something like that. But there's something feels just a little off, like how good our computers are at math and how little math I do on my computer. A lot of math is done on my behalf when I'm playing a video game, for instance, but I don't do a lot of math with my computer, and I feel like I would be using my computer more appropriately were I to do more math. And so maybe I just need to learn more math, but I don't know, there's something interesting about that, especially the simulation aspect. Because he's doing something that you couldn't really feasibly do without a computer. He also does like a statistical interpretation of like 5,000 phone calls. He gets this log of 5,000 phone calls that he types them into his computer twice to check for errors, which is ridiculous. And then he does some like statistical inference on it, and that's something like I think a lot of people can do something along those lines. Like there's a lot of people, I'm not great at Excel, but there's a lot of people who are very good at Excel. And I'm actually a little jealous of those people because I feel like that's something that computers are very good at, using, like, digesting and learning from huge tables of data. And it's kind of mathy too. So yeah, maybe this kind of tool builder person is always going to be an outlier. Like this guy is obviously a good programmer, knowledgeable about Unix and stuff. And he is, he's graduate level astronomy type person. So he's really knowledgeable about math as well. But this is his job. So it makes sense that this guy is good at tool building. But I guess where I'm uncertain is how much of an outlier this sort of person has to be. Could we make it easier for people to make their own tools, to respond to novel situations, to improvise, to use computers for the very specific purposes that they want to use them for, instead of necessarily whatever the company that made tools for them wanted them to use their computers for? So next section, I want to talk about the UNIX philosophy, which it might sound pretty familiar to most people. It's widely cited. It's rarely followed. Although I see a lot of a lot of programmers who are into this think of software this way, and write little tools in this manner. So I see a lot of it. I feel like I see a lot less of it in the consumer space. So Unix philosophy, part one, make each program do one thing well. To do a new job, build afresh, rather than complicate old programs by adding new features. There's scare quotes on features. So do one thing, do it well. It's a beautiful thought. I think it's mostly right. The only problem is that sometimes when you try to build a whole system of little pieces, you end up with so much complexity trying to coordinate the little pieces and get them to talk to each other perfectly, that you end up with more complexity than if you just build what's called a monolith. So there's this back and forth in the computer industry between microservices, which has kind of been a hot buzzword in the past decade, and maybe is starting to taper off a bit, and monolithic applications. And maybe there's a sweet spot. Maybe this will be in a forever war. Also, there's this famous case in JavaScript. The JavaScript ecosystem is all about pulling in packages that were written by other people to support the software that you're writing. And there was somebody did this little piece of software called LeftPad. That LeftPad is like adding spaces to the start of the line so you can like line some other lines up. And the developer of LeftPad like rage quit and pulled his software off, and it like broke tons of other people's software. So there's stuff to think about, but do one thing, do it well. I think there's something really strong there, especially when it comes to making your own tools and finding tools that are useful and composable to do the things that you actually want to do. And that very much goes into the next point. So point 2, expect the output of every program to become the input to another, as yet unknown program. Don't clutter output with extraneous information. Avoid stringently columnar or binary input formats. Don't insist on interactive input. So obviously this very much ties to, if you have programs that do one thing, do it well, they need to be able to coordinate or pass data to another, program. Like maybe the first one, processes the text and turns it into HTML, and then the next one does the next step. I don't know. I'm not very good at using Unix command line programs. A lot of times you'll search, you'll use one program to list all the processes running on your computer, and then you'll pipe that into another program that narrows down that search into the things that you're interested in, and then you'll pipe that into like awk, which will kind of reformat that text into the format that you actually want, and then you'll pipe that into a file, and you'll save that as like a log. Things like that are very Unixy ways of using computers. As mad as I am about iOS's allergy to user-built software, I actually find the iOS music ecosystem to be one of the best examples of this in the modern world, especially from a consumer perspective, because it's all these little pieces that work very well together. There's this AUV3 standard, and so you can have programs that either run independently or host each other as like little mini effects. If you've ever used like a music program or a DAW and you use like VSTs, like little effects that you can wire up, it's kind of like that, but kind of more powerful because it can also go across multiple programs. So you'll have like one program to generate a sequence of MIDI notes, right? And then you pipe that into your synthesizer to generate audio from those. And then you pipe that into an effect. And then you pipe that maybe back to your original program that was sending out the MIDI in the first place. And then that's like where your audio output happens. It's very cool. So, number 3. Design and build software, even operating systems, to be tried early, ideally within weeks. Don't hesitate to throw away the clumsy parts and rebuild them. So this is kind of funny because Unix is like the oldest software in the world. I mean, like we're running computers. If you run iOS or you run Mac or you run Linux, you're running Unix basically. And I guess some parts of it do get thrown away and revised, but there is a sense where I would like to start over a little more often. But we're very tied to sort of legacy systems right now. We're built on kind of legacy systems. Uh, Number 4, use tools in preference to unskilled help to lighten a programming task, even if you have to detour to build the tools and expect to throw some of them out after you've finished using them. Another way this is commonly comes up is called a yak shave in programming, where you're working on a problem or a project and you realize that what would really help is a very specific tool, and then nobody else cares enough about this problem to build that tool, so you need to build the tool. So you start building the tool, and that becomes a bigger project than the first project, and then maybe that tool needs another tool to help you build that tool. And this is it's almost a disease in the mind of a programmer. Someone who's capable of building tools actually kind of can sometimes get stuck building tools. The solution is just to build more tools, obviously, because then there's more tools, and then maybe once in a blue moon, when you reach for a tool, it's there, and then you can actually get that original project done. But who knows? Something to think about. Okay, new section. I wanted to bring up Smalltalk, and I can't go very much into depth of this because I don't really know a ton about Smalltalk, but I've seen some really cool demos. And it's kind of an example of how computers can be more improvisational. There's this concept in Smalltalk called reflection, which is mostly just not a modern thing that happens in most mainstream software. Here's a quote from an article I found about it. A reflective program is one that reasons about itself. A fully reflective procedural architecture, Smith, 1983, is one in which a process can access and manipulate a full, explicit, causally connected representation of its own state. Yeah, right? Causally connected means that any changes made to a process's self-representation are immediately reflected in its actual state and behavior. So basically, think about your computer, right? And you're running some programs. What can you change about your computer right now? Like, you could change your desktop picture. You could change which programs you're running. You could change are you in dark mode or non-dark mode? Like, you could change maybe the theme of your UI if you're really advanced. But can you change the logic of a program while it's running? Like, a program works in a certain way and you wished it worked a little bit differently. It's the Smalltalk model. You could open up the code for that program and find the one little piece of logic that is responsible for the behavior that you don't like or that you wish was augmented somehow, and you change it while it's running and then go on with your day. Very powerful concept. Possibly very impractical to actually build. Like, there might be so many trade-offs to the difficulty of building a system like that maybe that's not ever going to really work. But there have been some pretty advanced systems that worked in this way. I don't know. It's something to think about, something to dream about, and dream for, I think, because it's very cool. It's very powerful and empowering. Next section, wearables. So I've been thinking about some of these things for a long time, and I've got a few pieces that I'm proud of. I think of as like at least checkpoints in my road to thinking about computers more in a kind of a critical way. So I wrote this piece in 2012 about wearables. It was kind of a fun one because I did a lot of the research for it before I left the internet, and I had archived and downloaded as much as I could find about wearables as my resources, because I was about to leave the internet and then I wouldn't be able to use the internet to investigate this piece. So it was pretty fun. And obviously arbitrarily difficult. So the big thing that was happening then was Google's Project Glass. And I was pretty sure that they were kind of headed in the wrong direction because there was some aspect, it wasn't very computery. It was an interface to Google services, which is fine and interesting, but not what I want computers to necessarily be. And so I found these interesting references to like in the history of wearables of how computery they could be. So here's a quote from my piece. I'm sorry for how self-referential I'm being. One of the first applications of a wearable computer was beating roulette. Nerds have been bringing computers into casinos as early as the 60s, culminating in the 80s with serious wins at roulette. Thomas Bass, who wrote the definitive piece on wearables for Wired in 1998, smuggled a shoe computer to a table, gaining a 44% advantage over the house. Now, the quote continues. Predicting roulette is using a computer for something only a computer could do. It's taking in the same visuals as a human, but then running complicated calculations to predict the deceleration of the wheel, the movement of the ball, and eventual landing spot. The problem is similar to landing a spaceship on the moon, writes Bass, except all the calculations have to be done within the few seconds between the launch of the game and the croupier's, I think that's how you say that, call to place your bets. End quote. So I think that speaks for itself in the sense of a computer being used in a computer way, right? So the piece also digs into a concept called effective computing, which have also referenced. I really should have just republished this Thomas Bass article because that's really what it was all about anyways. Okay, new quote from my piece. In Bass's Wired piece, he spends time with Jennifer Healy, another Media Lab graduate student working in the effective computing group. She lived life with electrodes on her face to track when she was smiling and frowning, rings to measure the conductivity of her skin, like sweat, and a heart rate monitor. A Palm Pilot tracked the data, and an earpiece could let her know how she was doing. Quote continues, your wearable computer could whisper in your ear, writes Negroponte. So I'm referencing some piece by Nicholas Negroponte now. Perhaps after playing for a few too many hours with a few too many kids, patience, the birthday party is almost over, is what the computer would whisper into your ear. Okay, end quote. So that sounds creepy if Google or Facebook tried to do it for you, right? Like, this is something that's really impossible to be given to you by someone. It's kind of something you, in a sense, have to cobble together or build yourself just so that it's trustworthy somehow. Or find some very different kind of company that could provide this sort of thing to you. But I think it's skateboard-like. I think there's something about wearable computing that's possible, that's very interesting, where you use computers as computers to do things that computers are good at, to solve. I think what's important is novel problems. You know, it's the skateboard versus the bike and the velodrome thing, where like the improvisation and recombination, you know, the small tools of UNIX versus here is the direction around the track that you must go, you know, where when someone builds the software for you and has this whole ecosystem tied to it, and it has some sort of momentum and direction, and they've got sort of their own plan, and they're trying to feed their own machine learning algorithms with the data about your own sweat, you know, it goes awry. But if it's small tools that you can compose yourself to solve your own novel problems, like maybe getting angry at birthday parties isn't your problem, but you're trying to track, you know, a very specific mood that you feel certain times that you want to know what it's coming from. And it turns out it's like whatever you eat, eggplant. I don't know. But that kind of thinking, I feel like is could be interesting, and it needs a more of a skateboarding approach. Okay, new section. I think I'm definitely over halfway done. Another article I wrote is about the Dyson sphere, which I'm really proud of this comparison because I think it's a really fun way to think about how much of ourselves are our computers capturing in terms of user interface. It's kind of along the lines of effective computing, where the computer, sees that you're sweating or that you're smiling. So the Dyson sphere, if you're not familiar, here's the definition from Wikipedia. A Dyson sphere is a hypothetical megastructure that completely encompasses a star and captures a large percentage of its power output. And I'll just speed to the end. Not that any of us have ever done this, but this is the last paragraph of the piece. Ultimately, it's not that I want to use less of my computers. I just want my computers to use more of me. Luckily, most of the things I've outlined here, things about voice and video and, the Kinect and touch gestures, things like that, are obvious and inevitable evolutions of computer interaction. What scares me is that in the meantime, we'll get so hung up on natural user interface that we'll just use fancy new gestures and voice commands to do the exact same tasks we've been doing with perfect speed and accuracy for years. So natural user interface was a big buzzword at this time. I think this is 2011. I don't hear that as much, maybe because in some senses we have adopted them in the sense of Alexa and Google Assistant, that kind of thing. In other ways, like memorizing complicated gestures to tell your computer something has definitely not panned out. My metric for it is this mode of interfacing just as easily done with some buttons or a keyboard? I remember just being so utterly disappointed in Kinect Star Wars when I got to test it out. Because I was so hyped on Kinect. Kinect is a user interface that's pulling in more information, right, from the world. You could make a 3D representation of a person and then kind of map that to a bone structure. Like you could kind of make a pretty good skeleton out of you, and then use that in the game somehow. And I don't know if there's this like Japanese game show where you like pose as kind of like a Tetris piece and this wall comes at you and tries to you try to fit that very specific shape that's cut out in that wall so that you don't get knocked into the pool or whatever. That's what this Kinect game was like. Instead of using sort of your analog motion and the subtleties of your motion to do something in the game, you basically try to match a pose that would be mapped to a specific action in the game. And it's like you're doing so much more work and the output is exactly the same if you hit the A or the X or the Y button. It's very dumb. Now we have like Beat Saber, which is fully analog, and you swing your lightsabers full freedom in all dimensions. And it's amazing. And the game, it doesn't have the Star Wars IP. You're literally chopping blocks that come at random angles, and it's so simple, but it's so satisfying because it really captures analog data. You could not recreate that with buttons and a joystick or something. Along these lines, something that I found really interesting is Google Lens. I think there's something to it it's a little more computery than like maybe, remember I was mad about Google Glass. Like your computer using your phone's camera and the power of Google's machine learning, but also their search, you can do some really interesting things that aren't very possible without this functionality. So like Google Lens, like, you take a picture of a product and then it finds it online. I think it does things like that. They've got a new example out that I'm kind of excited about. Like it's copy and paste text. So you could write a note out and like take a picture of it with Google Lens, and then becomes text that you can copy and paste. It feels kind of like a tool, not just like an appendage of Google, because, copy and paste is well understood and then very recombinable. Maybe that's why I find it more interesting. I also think it's funny that I recently like super doxed myself. I was trying to scan my driver's license and social security card, and I was taking a photo of it, and this little thing popped up like, oh, it looks like you're trying to scan a document. Do you want to like, because I know the camera has some mode where it like will take when you take a picture of a document, it will like kind of flatten it out and like reorient, kind of make it look like an actual real scan. So I was trying to, I saw that pop up and then it disappeared, and I was trying to find it. So I switched to Google Lens, and now Google Lens like lights up, and like I could just imagine like what is actually happening with this thing right now. Like it is reading, highly identifying information about me, and then like transmitting it to Google servers, and like is it doing a Google search with my social security number right now? I don't know. It was hilarious. I try to keep most of those Google features turned off, but Google Lens is so interesting. I don't really use it a lot, but I like to think that I might. So maybe my summary for this part is that maybe we can have nice things one day. Probably not, but maybe. I realized that didn't maybe totally tie into the skateboarding thing. But again, I'm just presenting some ideas and some questions. Are we using computers correctly? Is computer skateboard for the mind? So that's what I've got. That's where I'm at right now with that. Those are some of the things I'm thinking about along these lines. Improvisation, recombination of tools, tool building. So just going to give you some takeaway resources if you want to dig into some of this stuff. Maybe this is tangential as well. Who knows? So there's some cool people I like in the computer industry who, because a lot of what is making this difficult is the inherent complexity of our computers. They're so complex that how could we engage with them and write tools for them? Because it takes 1,000 Google engineers to make a piece of software. So like, how could I make one tiny useful tool? But I think it's possible that there's a lot of the complexity of computers is unnecessary. It's accidents of history or, a certain corporate pressures or whatever, and possibly some of it could be unwound. So some of the people I really like on this are Jonathan Blow, Casey Muratori, who they're both pretty loud on Twitter, and they kind of come across as curmudgeons, and I want you to forgive that. They are mad at when software is worse than it needs to be. And sometimes it's unfair because I think every developer writes something that is not up to snuff or it's not perfect for sure. But what they're pointing at is there is a lot of lack of knowledge in the current programming community, and a lot of people building on top of other people's abstractions that they don't understand. And that's how you end up with sort of too complex of systems for anybody to understand. Jonathan Blow has this really good talk. Ooh, let me find it. Actually, I forgot to write this down. Okay, yeah, Jonathan Blow has a talk called "Preventing the Collapse of Civilization," which is a must-watch. Casey Muratori has a kind of like not a fanciful, kind of actual practical way to unwind the complexity of like the current operating system computer stack. Let me find that. It is called the 30 million line problem. And then there's also a really good talk by Joe Armstrong, may he rest in peace, called "The Mess We're In." That's really cool. I also recommend the On the Metal podcast for some technical deep dives in it is very technical, a lot of this stuff, and that's kind of, I get drawn into that because that's what I'm interested in. None of these are super practical ways. Here's how you can make your own tools and make a computer like a skateboard. But maybe they're like reasons why you can't. Maybe. So there's actually this something that gets brought up a lot on the Metal podcast is like the complexities of BIOSes, like the operating system that lives on your motherboard, that when you boot your computer, that operating system boots up, like gets everything running and then boots to your real operating system. Like I'm definitely in a case like right now where booting to my BIOS takes like 15 seconds or whatever. Booting my operating system takes like 1 second after the BIOS is like all ready to go. Something like that. I'm probably exaggerating, but there's like some wild complexity that really doesn't seem like it needs to be there. And there's a lot of people who are fighting the good fight of trying to simplify some of this stuff for selfish reasons and for like really noble reasons. And it's just cool to know that kind of stuff is happening. Also, Jonathan Blow's on the Metal podcast. They talk to a lot of old timers. You get a better vibe of what systems were like back in the day. There's this guy who makes his own like internet company, like as far as internet infrastructure, which is really helpful for understanding how the internet works. Very good podcast. So that's what I'm thinking about. That's what I'm into. Hope this is clear and helpful. Interesting. That's what I'm going for. Interesting and like discussion starter, right? That's my angle right now. I will have a new podcast next week sometime. I've got an interview lined up that I'm seriously excited about. Thank you to everyone who's been listening and subscribed. Huge thank you to my Patreon supporters. It feels weird to even say that, but there are people who are supporting me on Patreon, which is wonderful. So yeah, that's the pod. Thank you for listening. Paul.